live. So I hope we're live right now. Welcome everyone. So just let me check the last checkpoint of the stream. Yes, it's working. Great. So welcome everyone to another edition of our PyLadies Amsterdam session. Today our session is dedicated to the introduction to data science using Snowflake and Snowpark library. So what's going to happen today? We are staying together for 1 hour and a half. And then at the end, there will be a small surprise. So for those who are interested to stay until the end, stay with us. And for the rest, what's going to happen next? If you have any questions, feel free to send a message here on Zoom. If you're watching the YouTube stream, feel free to ask your questions in the chat on YouTube stream. And we prefer not to interrupt the speaker, but if the question is really, really urgent, of course, we're going to be with you. So without further ado, we give a space and the possibility to introduce herself to, if I pronounce your name correctly, Tatiana Petracha, right?
Perfect.
Okay, cool. Yes, the floor is yours.
Thank you so much. Let me also start sharing my screen. Can you please confirm it's visible?
Yeah, it looks like it's visible. Let's just check it with the stream as well. So Nancy, is it visible in a stream?
On the YouTube studio, we are live.
Yeah, great. And I see the screen is visible, right?
Amazing, amazing. So let me start. Welcome, everyone. As announced, we're going to speak today about data science with Snowflake. And let me start by introducing myself. As you can see here on the first page, I'm a solution engineer at Snowflake. But let me also share some stuff about me. So I have over 12 years of experience in the world of data. I started with the traditional workloads almost 12 years ago. So did a bit of data warehousing, BI, big data, data science and machine learning. And now I'm with Snowflake. I have more of a generalist role, combining all my past experience. Personally, I like music and science, everything related to science. I'm like into books and podcasts. So that's about me. I also take part in various Snowflake events. You can see here one with Data Heroes. So we also have, so you are welcome to join those as well. Not sure, can we also do a show of hands? Maybe if how many of you know Snowflake? If you just can add like a reaction here, maybe a show of hands, or just say yes. Okay, I see some. Nice. But don't worry, because by the end of this session, you're gonna know a lot more about Snowflake and data science with Snowflake, which is made possible via the new developer library, which is Snowpark. And this is the agenda I prepared for today. We're gonna have some theory in the beginning, because I think it's nice to have an alignment before doing the coding part. So the agenda and this part, I think these steps here are representative for any data project, not only data science. So we're gonna take it step by step. And the first fundamental step is to have your data foundation robust. Nowadays, security and governance, they are top of mind, especially when you are productionizing solutions. Then step number 2 is to simplify the data pipeline. And you're going to see what I mean by that. With Snowpark, the idea is to bring the code to the data. So that will definitely simplify the overall architecture and will have other benefits. I'm going to share those. Step number 3, data science is not like a one-person job. Usually it involves a lot of steps and teams collaborating, such as data engineers with data scientists, with data analysts, DevOps. So the idea is to how Snowflake can support that multiple workloads in parallel, which can be scaled up and down, and with elastic processing. Then we're gonna do like what's the core of our workshop today is train and deploy a machine learning using the tool of your choice. So I suggested on GitHub Visual Studio Code, but you can use whatever IDE you want that supports Python. And I would say that most of our job as a data scientist and with this model deployment, but I think it's really important to also focus on how to make this model actionable. Sometimes this model are going to be used by the business, and it's a black box. So I'm going to show you how you can create an interactive web app that the business can use and in a friendly way and start to trust and get make decisions based on those interactions with the web app. So this is the agenda. And let's also define the business problem for today. I want to be a mix of technical stuff, business, and coding, because this is how it happens in the real world out there. You start with the problem, but that's a problem that will solve a business requirement. And what we are solving today in our workshop is an optimization problem. So the idea is how to optimize spend across channels for this sports retailer. It's a fictitious company, Sports Co. We have here the CMO, is the Chief Marketing Officer, and he wants to find what would be an optimal manner to allocate budgets across, it's an omni-channel, across these various channels. You can see here on the screen, like search engine, video, and so on, so that they can, of course, increase ROI, return on their investment. For that, he's gonna get help from his team. John, he's the data engineer, and Emma, she's the data scientist. So we're gonna play multiple hats during this workshop. But John now, he has some challenges with managing clusters, and it takes a lot of manual work to configure and scale up those clusters. And Emma, she's a data scientist. She's waiting for John because there's like not enough room in the cluster for her to start her data science job. And now she also has to learn front-end programming. So that's the current situation, and we're going to see how Snowflake will enable all the team members to work together. And this is these are the challenges with this specific team. But in the real world, these are common challenges, but I would say even more challenges. And now let's have a look at the higher set of challenges that prevent a scalable and repeatable process to take model from development to production, because at the end of the day, that's the job of a data science team, to productionize models. And here I'm sharing it's a simplification of the process, of course, but I'm referring to the data science process as having two parts, development and production. And let's see some of the challenges. At the foundation of these both processes is the data. And when I'm saying data, I'm also referring at access to data, governance, and how efficiently the users, the programmers can process that data in order to transform raw data to features that can be used either for feature engineering or for model inference, or both. And you see here the gap, that, let's say, like the great divide between development and production. The thing is that during the development, the data scientists have to be really agile because they are performing multiple experiments. So they need quick access to the data and to compute, to iterate to these experiments. And meanwhile, in the production, and you see here different personas, can be a data engineer, a machine learning engineer. They have other objectives, a little bit different. It's all about automating these pipelines in order to generate predictions at scale and in a scalable and secure manner. So how we can summarize these challenges? One would be broken data foundation, which slows down the development and creates a bottleneck in scaling the production pipelines. Why is that? Sometimes, and this is under the processing complexity umbrella, sometimes there are different programming languages being used on the development side versus the production side. For example, Python versus Scala or Java, I don't know. So a data scientist can work in an infrastructure, and a machine learning engineer or data engineer in a different infrastructure. And that also results in different silos of teams and tools and silos in data. And it ends up like the teams, they are doing a lot of each other's work with limited collaboration. So this is the landscape out there. I see these with multiple customers out there. Not sure if it's your experience, but I think this is a good summary from, at least from my experience and from the feedback I'm getting. Now you're probably wondering why Snowflake? So how can Snowflake help? And of course, this is the topic of today. And I'm gonna link the challenges, and I'm gonna offer you now a solution how Snowflake can help with this, close the gap between development and production. And the answer lies within Snowflake's architecture. So it offers unified data access, a performant elastic engine, which can be used for multiple workloads in isolation, and multiple languages, not only SQL. Maybe some of you that know SQL, traditionally Snowflake could support SQL, but now with Snowpark, it can support multiple languages. And what's also really important, it's a fully managed software as a service platform. Remember the pains of the data engineering in the beginning when I was presenting the business use case. So you don't have to worry about partitioning or managing the infrastructure. That's out of the box with Snowflake being a fully managed. And let me also explain a bit how the architecture works. In just a few words, it's a multi-cluster, meaning you can have multiple cluster and isolate workloads. Shared data architecture, so every workload has access to the same single source of the data. So that's already says a lot. And you see here the layers, and all these layers are decoupled from each other, but logically they work together. So let's also look at the architecture. So you get a better sense of why this is helpful with the challenges I was mentioning. Now it's fully managed and it's cloud agnostic. You can deploy Snowflake on top of these major cloud vendors. And you can distribute data across multiple regions, across clouds, and with the same experience. Now let's look at the centralized storage. So this is a single place to centralize all your data, structured, semi-structured, unstructured. And I said it's fully managed. So the data is automatically compressed It's encrypted and divided in partitions for you. That makes the query execution really fast because you already have this, what we call micro partitions. And what is cool is that the compute is separated from storage. And what does this mean? It means that you can spin up clusters really fast and run multiple workloads. You see here these different boxes. Each can represent a different workload. For example, here I can have a ETL workload. Here I can have a data science, or here I can have a web app, which can scale out or horizontally automatically. So not only this, but it also separates compute from compute, which means you have the flexibility of scaling out each workload independent from each other. And with Snowflake, you pay per second. So that's also really nice. And the last layer, we call this at Snowflake the brain of the platform, is like an air control center. So it knows what partitions belong to what table, is responsible with governance, security. It takes care of optimization and so on. So that's in a nutshell Snowflake, and you see here the benefits and how this can help with the challenges. Let me know if you have any questions so far. Hope it's clear. You can add questions on the chat or just speak. I love to hear your feedback. Okay, let me.
I would, sorry.
Yeah.
I would really like to know how I can select GPU and how I can select a proper environment. I mean, PyTorch or something like that, proper CUDA drivers.
Mm-hmm. That's a very good question. So for the time being, Snowflake doesn't support GPU. And so only CPU processing. GPU will be added, but I don't have timelines. So that's one first comment. And I will show you when, after we create a trial environment, we call our compute clusters virtual warehouses. And basically there are two options: standard compute clusters. And these, mostly you will use those, and we're going to use those standard compute clusters for our workshop. But if you have high intensive memory workloads, there's a different type of compute clusters, memory intensive clusters. And I'm going to show you the options once we create our trial accounts.
So there is no option to select granularity in the means of CPU, RAM, and space for this, because data science processes are very compute intensive, and sometimes you need a lot of cores, and sometimes you need quite fast SSD disk to process data. Okay.
You can choose, because as I mentioned, this is a software as a service. You can choose the type of the compute cluster, and we make this really easy for you. It's in the we are using t-shirt sizes, so it depends how many cores. For example, extra small has how many nodes? Sorry, so it has one, or you can have multiple. So I will show you once we create. You have this flexibility, and if you're going to train a model, of course, you're going to choose a memory intensive compute cluster. Thank you for the question.
Thank you.
Now, yep. So now, because we're going to do data science today, I also want to introduce the library we are going to use. It's a new developer framework. It's called Snowpark, and it extends the SQL capabilities from Snowflake with other programming languages, such as Scala, Java, Python. We're going to use Python today for our workshop. The idea is you don't have to move data out of Snowflake. So the code is being pushed next to the data, which means you don't have to make any security or governance trade-off. The same governance policies that you apply in Snowflake are available in Snowpark. And this is the high-level architecture. You have a client and the server side. The client side is where you do your development work. And we are going to use the library. You can install it using pip or conda. And this execution, the code is being pushed down onto the server side. And what I want to mention is that all these operations are executed lazily on the server, which means that the amount of data transfer from the client to the server is minimized in this way. So this is just a high-level overview of Snowpark. And this now I want to introduce quickly Snowpark for Python. And why would you use Snowpark for Python? These are some of the benefits. First, you're gonna work with a familiar syntax. The core API is a data frame API. So I'm guessing most of you have some familiarity, maybe from Pandas or PySpark or some other data frame APIs out there. Another important benefit is the integration with Anaconda. So you have access to thousands of packages, and this the package dependency management is automatically taken care of, and you can look up. There's a dedicated Snowflake channel on Anaconda where you can see what libraries are available. Of course, you are not restricted only to those libraries, but also you can bring in your pure Python code. So that's possible. And how this Python code is being executed, it's being executed in a secure sandbox, which is built right in the processing engine of Snowflake. And it's basically doing data science in a fully managed platform. So that's the key takeaway. The idea is you focus on your data science task without having to worry about cluster configuration, and you're going to experience that yourself. How it works under the hood. Snowpark has two main abstractions. One is the data frame API, and it's really cool how it works because the client API, when you are writing queries using Python, it converts that code into SQL, and that SQL is automatically distributed across the nodes from a compute cluster. And we're going to see transparently how this happens during the workshop. And Snowflake knows how to optimize and quickly execute, efficiently execute SQL. That's like the bread and butter. And of course, you also have the flexibility of writing Python, and the main two abstractions are store procedures. And we're going to use a store procedure to train a model, and then user-defined functions. And we're going to use the user-defined functions to create a prediction function. So this will be like the objects that will allow us to train and deploy models, and how this execution is being pushed down. So this is the client and this is the server side. It's being pushed down because it's serialized into a Python bytecode, and you see also you have this integration with Anaconda. All this you can make use from your favorite IDE. And we also gonna see how, because we were speaking about the divide between development and production, In production, it's all about automating data pipelines, and you can see how you can automate your data pipeline using a task, which is a scheduler, the default scheduler in Snowflake. So this is in, by and large, this is what happens under the hood. And this is the flow that we're going to follow for the workshop. So we're going to load some data into Snowflake. We're going to transform and create training and testing data. We'll automate this pipeline using the store procedure, and we can add a scheduler. And then this part is going to be executed by John, our data engineer. And then once his job is done and automated, we're going to wear the hat of a data scientist. Emma remembered our personas from the beginning. She will train a model using and encapsulate it in the store procedure that will push the execution onto the server side, create a prediction function. And you see here, we're going to use the standard compute cluster. And I'm going to show you that other options are available. And we're going to share these results in an interactive web app using Streamlit. Streamlit, I'm not sure if you're aware, has been acquired by Snowflake, and soon it's going to be, it will run natively. Now it's in private preview, so we're going to use for our workshop the open source library. And yeah, let me see. And just a few words about Streamlit. It's an open source library. Maybe some of you have used it in the past. The idea is you only need to know Python, and it comes with a lot of wrappers on top of really handy visualization libraries out there, such as Plotly, Alter, and so on. And it's really easy to use. It has, so you basically import the library, and you see with this just 3 lines of code, you can create like a hello world app with Streamlit. And this is what we're going to do and deploy so that Stefan, the marketing, the CMO can make the best decisions to how to allocate the budget. So yeah, let's do some coding now. And because we have like the theory is there now. Now let's just make sure we go to GitHub. I'm gonna copy and paste. I'm not sure if this is
yeah, already done. Yeah, just in case, I just copied it to our chat.
Okay, perfect. I see it. So we're gonna use this repo for our workshop today. We also have some requirements. So Git, Miniconda, and we're gonna create a trial account, a Snowflake trial account, and we're gonna enable some a step here. So I suggest just do quickly a Git clone, open a terminal, Git clone, and just copy this and just make sure you clone the repo. And the next step is to create a free trial account. I'm going to do this. Let me open this in a new tab. I'm going to do this with you from scratch. So I'm going to just create something here quickly. I'm going to use my email address. Something. Okay, continue. So what's important is to choose enterprise, and I'm going to choose AWS for this workshop, and I'm going to choose EU Frankfurt. So these are the options: enterprise, AWS, EU Frankfurt. Then just click get started. You can skip this parts. And once you're done, so choose Enterprise, AWS, EU, Frankfurt. I mean, it will work with, but this is what I'm used to. Once you follow the steps, you can quickly go and check your email. And you should get an email like this. And just click to activate. Now you are required to choose a username and the password. I'm going to use this is a trial account, and I'm going to use the same password I used before testing the workshop. Please make sure to write down the password because we're going to use it in a subsequent step. So just fill in these details. Of course, this is a workshop. I don't recommend to do that in production, but just for simplicity, we're going to use username and password in clear. Okay, and now I have access to a Snowflake trial account. Hope you can follow along. Let me know if you want me to slow down a bit. Just
can I ask a question?
Yeah.
Where do you find the account again?
The account, you have to get an email and just click on activate, click to activate.
No. I mean, the one where you put in inside VS Code above the user and password.
Oh, okay. So you are one step ahead, at least.
Yep. Sorry about that.
Oh, no. That's a question from the future. No worries. So that's a good question. So you can copy and paste this from your email account. So that's the account. So just have a look at the email and just copy the first part before .snowflakecomputing.com. Okay. And you're going to get something like this. Okay. That's the account. Okay, so what you see here now, we have a Snowflake account, and what you see is the UI in Snowflake. And as I was explaining during the presentation, Snowflake separates data, and you have some sample data from compute, and we call the compute clusters warehouses. You already have one available, but you can create one. And when it comes to size, you can see, you can choose multiple depending on, the requirements. But for example, if it's going to be a memory intensive one, you can also choose the Snowpark optimized, which are useful for more memory intensive, such as ML, but not only if you are doing a complex query. So these are the compute clusters. And there's also something we need to do here. Go to billing and terms and click on enable Anaconda Python packages. Once these steps are done, let's go back to our README. And what you have to do is install Miniconda. This step is done. And let's go to our repo. So I suggest opening this project in Visual Studio Code. So now I switched to Visual Studio Code. Hope you can follow. And what will we do? Let me go here and preview the workshop. I can see the requirements as well. Let's create a virtual environment using Conda. So after installing Miniconda, I already have this here, Miniconda on my laptop. You will install the required libraries, and all these are specified in this YAML file, which I'm going to show you. And I think this is nice to have a look at, because you see all most of these are taken from the Snowflake dedicated channel from Anaconda, and you have here a list of the required libraries. So just make sure you create the environment and then you activate the environment. These are the first steps. And then before running the notebooks, let's also update the connection JSON file with our Snowflake credentials. And I'm also going to do this. Let me copy and paste this one's from here. I'm going to delete. Okay, so only this part. I have the same password. And as I mentioned, because I don't want to move between screens, I can write SQL here in my Snowflake account. I have worksheets. I want to write SQL within Visual Studio Code. What I'm going to do, just go in Visual Studio Code and install the Snowflake extension. That will enable you to, let me make it a bit smaller. That will enable you to write queries, and it has a lot of cool features like auto-completion and documentation and so on. So let me go here and let me sign out because I was using another account. Okay. I sign into another account, and you can use the same one from the connection. Okay, continue. And I'm going to copy and paste the password from here and the user. And I'm going to sign in. And next, just follow the steps here. Some of you may be faster than I am. Next step is to run the scripts and the notebook. The first script we're gonna run, you see here you have the number 0, 1, 2, 3. So we have a sequence here. Is to run the 0 minus setup SQL. So now I can run the SQL code. From Visual Studio Code, I can just do Command Enter. I'm using a Mac. So what I'm going to do here, I'm going to prep all the data and the objects that are needed for the workshop. So I'm going to create a compute cluster. I'm going to create a database, a schema, and I'm going to load some data from an S3 bucket. I'm loading CSV data, and I'm going to create some tables that are going to hold that data. As you can see, I have campaign spend, and this is aggregated data, daily campaign spend across channels, because that's, remember, the objective. I have some revenue, monthly revenue. So to find a correlation between revenue and the campaign spend. And I also have the past budget allocations and what was the return on investment in the past. And what I'm going to do with this data science exercise is predict the best budget allocation across channels for July. So, and the last step is just to create some handy staging areas to save the models, the training function, and the prediction function. So now that we finished with the setup, you can also have a look here, and you can see I have a database, I have a new schema, and I have these tables. And it's cool that I can also do a preview of the data. So that's quite handy. Instead of moving from one screen to another, I have this visibility from Visual Studio Code because of the Snowflake extension. Let's go back and run our first notebook. So please open 1 - Snowpark for Python. And now we are going to play the role of John. Remember, John is our data engineer. And what we're going to do, and let me close that perspective. We're going to do a bunch of data transformations. And how we're going to do these data transformations? By using the data frame API, and we're gonna also see what happens behind the scenes, how this code that we are writing is being optimized. For that, the main library is gonna be Snowpark, and of course you must select the virtual environment we've just created. So this is what I have here, Snowpark _ PyLadies. And we can just run cell by cell. I'm also gonna give you an exercise, and let's see who is able to come up with a response fast. So what I'm doing here, I'm just doing the imports. I'm gonna import the handy stuff from Snowpark, but I'm also going to import pandas, and you're going to see within the workshop that it's possible to convert from a Snowpark data frame to a pandas data frame, which can be handy. So the first step is to establish a connection, a secure connection between Snowflake and this notebook from Visual Studio Code. That's why we've populated in one of the previous steps the connection JSON. And let me run this. And what I get here are all the parameters, let's say, that I'm making use of: the user, the role. So I'm an account admin, what compute cluster, and the version of Snowpark. And now what I'm going to do, I'm going to load the data as a Snowpark data frame. You have all these kind of handy explanations throughout the notebook. There are multiple ways you can create a Snowpark data frame. We're going to use the first one by loading a table that we just created, but you can also perform a SQL query, read some files, or create a data frame from a list, and so on. Now what I'm doing is, maybe it's good to make this a bit larger. So I'm loading that data from a table as a Snowpark data frame, and I'm using this queries to see exactly what happens behind the scenes. So remember, in the slides, I mentioned that the client API converts this Snowpark data framing API into SQL. And what I also mentioned is that this execution is lazily evaluated. So what I get here is only the query that has been generated. I haven't used yet an action keyword, so nothing is being pushed down onto the server side. But let's see, and I'm doing this just for you to get used and see exactly what happens behind the scenes. Now I'm gonna use this in combination with the query history object, because I also want to retrieve the query ID. And let me run this. And now I'm using show, which is an action. And this query is going to be pushed down onto the server side. And I can use this query ID for debugging purposes. And just for you to see how you can have visibility, you can, Snowflake keeps track of all the queries that you perform. and you can also filter by a query ID for debugging purposes. Let me minimize this. Apply filters, and you see here the query, who generated the query, and you can also see the query profile, which is really handy if you want to optimize. This is just a simple example. But then now you understand exactly how the system and how the library works. Okay, now let's do some transformations. We're going to aggregate the data, and here you see I have the campaign, the channels, 4 channels, video, social media, and so on, daily spend, and the cost. And I'm interested in finding the total cost per year month, group by channel, and this is what I'm doing here. So I'm gonna use a group by, I'm gonna extract the month, I'm gonna aggregate, and I'm gonna also rename this as year and month, and I'm gonna sort by year and month. And when I use the show, which is an action, this code is being executed, pushed down onto the server side, and I get a preview of my result. So you see this data frame API is nothing new. It's the syntax is quite simple. So now it's your turn. Who can tell me which channel had the biggest cost in the year 2022? Just write your answer. I'm going to wait like 2 minutes and write your answer in the chat window. Or you just can speak up. So just to give you a hint, you will use the filter method to filter by year, and then you're going to do another group by another aggregate, and just let me know what's the channel with the biggest cost in 2022. Okay, I will reveal the answer because I don't see any inputs. So how you can do this? You can apply a filter, and this is the syntax. So now we are working, this object is a Snowpark data frame, and how you're going to do answer to this exercise is you're going to filter by year and say it's equal 2022. You're going to group by channel, and you're going to do aggregate by the total cost, and then sort by this yearly cost descending. So the syntax is quite similar to this one, the previous cell, and this will give you like the results. So we see the biggest investments were with social media. So that's what has been done in the past. I also want to just give you an example, and that was like the second part of the quiz, to visualize the monthly cost for that channel. And actually I have here sorry. Okay. I forgot to run the cell. So what I'm doing here, I want to show you how you can convert from a Snowpark data frame to a Pandas data frame, and I can use this Pandas data frame and visualize. I'm quietly installing Matplotlib because that was not available in the requirement in the YAML file, and now I can visualize the costs for that channel in 2022. We only have data for 5 months. So yeah, that's something that's not in the GitHub repo. Now let's continue with the transformations. And the idea is to find the total cost per each channel. And now we have this data in this kind of long format. And what we need to do is to pivot, make it into a wide format type of table. But luckily, we have in Snowpark this function, pivot. So we're going to run this cell, and you're going to see how easy it is to pivot the data per channel. And we're going to mention this 4 channel. They're going to be columns, and I'm going to calculate the total cost per year and month. I'm going to do some column renaming, but this is how my data looks now being transposed. So I have this. Let me make sure that all my calculations are saved. So I'm going to write back this as a table in Snowflake. And so this is me experimenting, but I also want to automate this data pipeline. So what I'm going to do is create a function. And remember, I mentioned you can automate this pipeline by using a task. I'm gonna create a function, and I'm gonna register this as a store procedure. And this is how you can do this. Just give it a name, use the function that we just defined. This is the packages that are going to be used within that store procedure. Remember, we created some handy staging area in the setup SQL. And you can give it a schedule, like run it every 3 minutes or every day. And this is how you can productionize the initial part of our data engineering exercise. Cool. Now we have sort of the features, the input for our data science exercise. We also need to add the target column to that part. So what we're going to do, we're going to load the data from the monthly revenue table as a Snowpark data frame. And we're going to perform some other aggregations to make sure that we are aggregating the data by year and month. So this is what I'm doing here, and I'm using show to make sure that I'm pushing down this computation onto the server side. And let me run this, and you see now I have the revenue, and what's left to do is to join this monthly revenue spent with so the campaign spent with the revenue spent per month. And basically now I can say I have my data pipeline ready, and I'm going to use this data for my data science exercise. Before automating this last part, let me also explain you how the explain method works like. So it's really handy because then you can optimize your code behind the scenes. As I mentioned, this is SQL, and you can also have this visibility and transparency over the execution plan. This is what happens behind the scenes when I'm running this bunch of transformations in like chained. So you can see exactly what happens. The table, these tables are being scanned. There's a join, there's a pivot, and so on. So that also gives you, as a developer, a lot of visibility, and you can then further optimize the code. Once I also have this, and I know I can save the results back into Snowflake as a table. And this is just an additional step I want to share. I'm basically automating, creating another function where I'm doing the transformation for the revenue table, and I'm doing the join with the campaign spend and the revenue. So I'm just repeating the same steps. What's different is that I want to have a specific logic in running these two tasks. So I will make sure that I will run the second one only after the parent task. So that's also cool for you to be aware of, that you can chain and have like parent-child tasks that you can execute in a sequence. This is how you start the tasks, and this is how you suspend the tasks. Of course, all these objects I'm creating, they are visible here in Snowflake. So if you go here and refresh the schema, you're gonna have the task. These are now available. And for example, someone can use them in a SQL or from the UI, the visual UI, which can be really handy when it comes to team collaborating together. Cool. And with that, we finish the data engineering task, and let's move to the machine learning side. Let's open the second notebook. For this, I'm going to focus mostly on what's new with Snowpark for Python. And you're going to see how simple it is, for example, to reuse some of your data science pipelines with scikit-learn, how simple it is to push that execution into Snowflake. Now I'm playing the role of Emma, the data scientist. So I get a question, the SQL file in the command line. So the SQL file, if you don't have the Visual Studio Code extension, you can just copy and paste the code from here. Just copy and paste and go into the Visual UI, open a SQL worksheet, copy and paste, and you can execute from here. So that's what you can do if you don't have the Visual Studio Code or the extension. Cool. So moving to the data science part, as I mentioned, now we're going to play the role of Emma. She's a data scientist. She has two main tasks: to deploy a model and to create a web application for the CMO, the Chief Marketing Officer, so that he can interact with that model and make decisions on how to allocate budgets. The prerequisite is for you to have completed the previous notebook. So they run in a sequence. Make sure that you are selecting the proper kernel, so the proper virtual environment. I'm using the Snowpark _ PyLadies. Check that. And I'm going to run all cells, and I'm going to guide you what's happening. So I'm not going to run cell by cell as I did with the previous notebook, because I want to also make sure that I finish on time. So it's the same part here. I'm using Snowpark. I'm importing the library, and I'm establishing a connection to Snowflake. So yeah, nothing new here. What I'm doing here is importing and making use of the table with all the transformations that John has made. And this is a data science exercise. So I'm gonna do like the easy stuff. Of course, there are multiple ways on how you can treat missing values. You can do imputation and so on, but I'm gonna do like the easy way now. I'm just gonna drop the null values, and I'm also gonna exclude the columns that are not needed for my modeling exercise, year and month. And I'm gonna save back this table, the cleaned with clean data. So this is how my features, my table with features looks like now. And once I have, now let's say Snowflake acts like a feature store in a way. Once I have this feature stored in Snowflake, all the data scientists, data analysts can make use of the single source of truth with my features. Let's do some model training. Of course, it's going to be a simple exercise. What I'm doing here, so remember, I'm going to predict what's the revenue for different budget allocation across channels. So it's going to be a simple regression exercise. Okay. I see people helping each other. That's nice. I'm just looking a bit at the chat window. So
No worries. It's always nice to have thanks for answering questions of each other.
Cool. So what I'm doing, and remember, I've run all the cells because I use run all. So what I'm doing is just a simple linear regression exercise, and I'm going to define a function that will train a model, and I have here an option to save the model or not. Why is that? Because let's have a look at the parameters of this function. So I'm gonna pass as parameters the table. If I want to do cross validation, which is always nice to make sure that the model is able to generalize as well as possible. I'm going to add some more features. That's why I'm using these polynomial features as a pre-processing step, but be careful with how many polynomial feature degree you choose, because that can do that can result in overfitting. And I'm also adding these thresholds because I want to make sure that only certain conditions are being met. I'm gonna publish this model to production. So it's just a simplification of what you would do as a data science pipeline before promoting your model into production, into the production environment. So I have these handy parameters. Now what I'm doing, and there's no rocket science here, I just want to show you how easy it is to integrate with an existing pipeline. I'm going to use scikit-learn and all the nice and goody things from scikit-learn, such as column transformers, a bunch of transformers, this estimator, linear regression, and the idea is I'm going to fetch the features from Snowflake. So Snowflake now is my feature store, acts like a single source of truth. And to be able to link this with all the objects from scikit-learn, I'm going to convert this to pandas. Remember, I already showed you briefly how you can convert a Snowpark data frame into a pandas data frame. And this is what I'm doing here. Now this df object, it's a pandas data frame. And what you can do from this line down, you can just copy and paste. It's like, okay, now I'm using a pandas data frame, and nothing new for the ones that have a little bit of data science experience. What I'm doing, I'm selecting the numeric features from my table with features. I'm going to define a pipeline. So I'm just defining, I'm going to get some polynomial features, and I'm going to scale this, and I'm going to apply this pipeline to my numeric features. And the next step, let me make this a little bit visible. I'm going to link this pipeline where I'm pre-processing the data. I'm going to chain it with this estimator, which is linear regression. And I'm defining my features. I'm just going to remove the revenue, and the revenue column is going to be the target for my data science. Cool. Now, what I'm doing, I'm just following the regular steps. I'm defining a training and testing data sets, and using 80% for training and 20% for testing. I'm going to apply a grid search to find the best fitting model. And then I'm just fitting a model to the data, and I'm saving the scores. Because why I'm saving this, because I want to make sure that only if the training score has a certain accuracy and also the testing score, then I'm going to deploy this into production. Now what you see here is just a plain Python function, and before pushing down this execution into the server side, I just want to just do a quick test just to show you how it works like. If you have, of course, large volume of data, you would want to push down this execution directly onto the server side. But now I'm just defining these parameters, and I'm choosing to not save the model because this is just like a dry run. And you see now what are the results of the training exercise. So I see that the results are nice. So now I can create a store procedure. Remember, the store procedure is the abstraction, the object in Snowpark that makes sure that my Python function is being pushed down, serialized as Python bytecode, and executed onto the server side. So now what I'm doing, I'm going to register that Python function as a store procedure. I'm going to pass the packages, and the server side will know to install all the dependencies because it has that native integration with the Anaconda package manager. And yep, and then I'm gonna say, yes, I want to save the model because now I know that those conditions are going to be met. And I'm just going to call that store procedure by name. And here I'm just mentioning all the parameters that I've assigned values for. So you see here now with this piece of code, I'm making sure that all that code is being executed onto the server side. And I can examine the query history in Snow side, but you see here the results, and the passes have been met. And what I can do, let me quickly show you refresh this. And let me show you that indeed this piece of code has been executed onto the server side. I have a model, which is the result of my training, available into this folder. So this is how you check, also as a check that, again, this code has been executed onto the server side and I have some results. Cool. So let's go back because I want to go back here. So we've done this step. I showed you how you can automate the data pipeline using a store procedure. We've done this step, the training. We saved the model into a stage. You saw the zip file. And what's the remaining are these two steps. So what I'm going to do here next, and as I explained, we're going to use a store procedure to train a model. So this is the abstraction we are using from Snowpark, and we're going to use a user-defined function to define the prediction function. And there are two, let's say, main categories of UDFs, but there's another one. I'm not going to go into details, but for the sake of this exercise, we're going to play with a scalar user-defined function. And this is what we're going to use to do online predictions. But I'm also going to show you how you can define a vectorized user-defined function for batch or offline predictions. And what are the differences? So the idea with a scalar, as the name says, it's going to return a scalar. And this is another way, I'm using this decorator, and this is another way on how you can register a function using Snowpark. So this will make sure that also the execution of this function is going to be pushed down onto the server side. So what I'm doing here, I'm just importing the model and the handy packages. By the way, in the previous part, I didn't specify a specific library, but this is how you can also freeze versions, which is of course handy if you want to productionize and make sure you're going to get repeat this deployment. And what I'm doing here, I'm importing the model and I'm just applying predictions using the predict function from the model, and that will return me a scalar, a float. We call this scalar user-defined functions. And the good thing is now with this prediction function, I can use it in my end-to-end data pipeline, but I can also use it. And let me also go here because I want to show you the graphical UI again. Let me refresh. And you can see here available as a function and as a first-class citizen in the Snowflake ecosystem, this predict ROI user-defined function. Why I'm showing you this? Because then you can use this not only for your machine learning workflow, but you can use it within a SQL or from your BI report or from a dashboard. That is really handy. How fast is this prediction function deployment and how the entire ecosystem of users can make use of it. And this in conjunction, let me show you something else. I'm deviating a bit. This in conjunction with the multi-cluster warehouse will make sure that you can meet the demand of many concurrent users, because Snowflake will know how to automatically scale horizontally. For example, if you are employing this predict function from your dashboard or Streamlit app. So this is what you're going to use for the online prediction in the upcoming step. But just as a parenthesis, some accolades, I'm going to also define, and this is how I'm calling, and I'm going to show you how you can call this from Streamlit. I'm just defining a dummy data frame, and I'm passing a list because there's a signature of my function. And now I have, for my input features, I have the predicted ROI. And I also want to show you how you can define a batch or a vectorized user-defined function for batch predictions, offline predictions. And the only difference is that I'm gonna, instead of having a scalar, I'm gonna have a Panda series. So as a result, because I'm applying this not row by row, but over batches of rows. And something really nice I also want to showcase is how you can cache the model, because that will make sure, and I put here a mention that will make sure, so using this library will make sure that you will only load the model once, which of course it will give you better performance. If you want to apply prediction on top of billions of rows in Snowflake, I really recommend you to do a test and time the execution on over how is the performance when you are executing this row by row versus batches of row. So this is an example. You see here how the signature, since the signature of the function has changed, I'm also calling this function, I'm giving it a data frame as input. And with that concludes our data science exercise. I will just spend 5 more minutes and show you how you can create a Streamlit app. So let me go here and open this other, I'm not sure, this is just a Python script, it's not a notebook. And for this one, I'm gonna use Streamlit, open source library. As I mentioned, this is gonna be natively integrated into Snowflake. And let me just quickly run this and then I'm gonna explain you what I'm doing. So make sure you have your Conda environment activated in your terminal window. And you can just copy and paste from here. This is the command. This is how you're gonna run the Streamlit script. And let me quickly run this. And this will load the web application. And while this is loading, you already see a bit the layout of my Streamlit application. And let me move back here because I just want to quickly explain what I'm doing here. So I'm importing a bunch of libraries, and Streamlit, as I mentioned, works as a wrapper on top of many cool visualization tools, such as Altair, for example. And what I'm doing, I'm just creating a session because I want to read data from Snowflake. And I'm also configuring the layout of my Streamlit application. You're going to see I'm going to give it a name. I'm using an icon. I'm adding a title. You see here. Then I'm also going to define 2 columns. Actually multiple columns. So I'm just defining the layout of my application. So that's actually really easy to just, instead of using React or JavaScript, you can just quickly, by knowing basic Python, you can make use of this application and quickly create interactive web app. What I'm doing here, I'm also making use of my UDF prediction function, and I'm using it in a SQL. And I'm going to show you that. So here I'm defining a bunch of charts that I'm going to overlay one on top of each other. You see here, so I have bar chart, line charts. So I'm just defining how my charts will look like. And I'm also gonna make sure that once I have the best results, and now I'm gonna be the CMO, I'm gonna save these results back to Snowflake. So let's play a bit. Let's say I wanna invest most of my money and allocate most of my budget into the search engine and decrease the video and so on. And so I can just play with these sliders, and you already get a sense that, yeah, putting most of the money into the search engine, that will already increase the ROI from the previous month. So once I'm happy and I can understand how the model behaves, I can save my results back to Snowflake. That will append, browse in the table where I have this budget allocation. So I can generate a different scenario. For example, this one is quite bad, but just for the sake of it, let me save this to Snowflake. And I also want to show you that, yeah, indeed, data is being written back. So you see, all these simulations are being saved into the budget allocation and ROI. And let me go here, tables. And let me show you a preview of the data. So you see, I already have two options, and this one is way better. It generates me a really nice ROI. So coming back to my slides, here you can see that we managed to create a really nice web application, play the role of a data engineer, and then use Snowpark to train and easily deploy a model into Snowflake. Now that model is available to be used in my data pipeline with my Streamlit app and so on. And how I've done all this is by bringing the code to the data, working with the familiar syntax, the data frame API, and now I've introduced these two new abstractions, store procedures and user-defined function, by also making use of the fully managed capability in Snowflake and the scalability of the ecosystem. Now the CMO, Stefan, is really happy with these results, and it can make sure that his business will grow. I want to leave you with this. Now you have a trial account. I hope you're gonna make good use of it. And possibly, if you like Snowflake and Streamlit, you can join this cool hackathon and win a trip to Las Vegas. So I highly suggest to play around, and who knows, maybe you'll be one of the winners. So you have time up to 5th of May. And let me know if you have questions. I'm done because I know that the organizers also want to make some announcements.
There's a question on the YouTube channel. Do we have time?
Yeah, go on.
So Nina Selesneva asks, Snowpark functions appear very similar to PySpark ones. Does it use it under the hood? Should one expect all PySpark functionality to be available in Snowpark?
So you're gonna see similarities when it comes to functions and syntax, but the architecture under the hood is really different. So under the hood, we are not using Spark clusters. As you've seen in the workshop, when you are working with the Spark, with the Snowpark data frame API, the code is generated as SQL, and that SQL is distributed across the nodes within the compute cluster in Snowflake. So it's totally a different way of executing. And just remember, Snowflake is fully managed, so you don't have to worry about managing the compute cluster.
Thank you. I hope that answers the question for this person.
Yeah. Okay. I think if you want, you still have time for, let's say, like 1-2 questions, and then we will finalize to the surprise that we mentioned. But I think Tatiana already also shared some really interesting surprise. So go on and try to go through the hackathon.
You can escape. Sorry, I'm not sharing, but just Control C, in the terminal window.
Or Command C, right? If you're
Command C, yeah.
Anyone, you have still time for one more question.
If it's Mac, I'm using a Mac. Yeah, sorry.
Yeah. No worries, no worries. Okay, so while we're waiting for the brave person to come up with the last question, so we have a small announcement for those who stayed with us until the end, and for those who are really interested to dive in deeper into the knowing the architecture of Snowflake, how Snowflake does work, and to get this, let's say, the first-hand experience, we have a small gift from O'Reilly from Safari Books Online, and we have literally 5 books. It will be not printed version, it will be online version available for you, for the participants of this workshop. And if you want to get this book, we can run a raffle. And basically what we ask you to do, I'm typing right now our email address so it's available to everyone. So for those who attended this session, you have time to say, I want this book, I want Snowflake book. Just send this email to this address. Let me double check the spelling, Nancy.
It
Yes.
looks good to me.
Yeah, so literally send a message to us. I want to get this book, so you can further investigate what Snowflake can mean for you. And I think we can give people a little bit of time, right? So what if we say, get back to us until the end of this week? Let's say in the night, we're gonna literally shut down this. So looking forward. I'm really, really curious. Tatiana, we're going to share with you then who our next Snowflake person you're probably going to work with.
I have a quick question. I think so thanks a lot for the presentation. Well, because I know it's more like a data scientist and machine learning oriented, but as a data engineer, what I saw that a lot of the how to say deployment, if I understand correct, everything can be done in the notebook, and even mentioning the task, how it's executed, what stage, and etc. So I'm just wondering, if you have like a lot of things going on, then it's gonna become like a monstrous long, everything gonna be squeezed into one notebook? Or how does it work if I want to manage it better in terms of, let's say, the staging would be separated in another file? It doesn't make sense because, you know, I just see one notebook and everything is in one notebook. I kind of getting a little bit afraid of having, you know how it is, like hundreds of notebook, everyone is deploying stuff, and then you try to go through the code and they're repeating the same thing. That's the kind of same nightmare for the data engineers experiencing every day.
Yeah, that's a very valid point. Of course, this is just a workshop and I try to simplify and make it interactive. That's why I use notebooks. But to make it production ready, I suggest saving all these functions in a separate folder module, Python scripts that you can link together because most of this logic will have some dependencies. So you're going to create like a sort of graph of functions, and you can automate the execution depending how your business logic looks like. You can automate using store procedures and tasks, because with tasks you can also specify this is the parent or the root that's gonna trigger the execution, and then these subsequent steps are children of that parent task. And you can also see like the execution, the dependency graph as visually in the UI. So I didn't show that, but if you have like a dependence task with many dependencies, you have like a handy visualization in the UI, which is
that's really nice, but not in the free version.
It's available, but for example, you have a trial account, and what I suggest is to execute that task, because I quickly suspended. I should have waited at least 3 minutes. So if you wait, now you have a trial account with credits. So I suggest execute, repeat the steps, and look how the task looks like in the UI, and you're gonna see a dashboard for that task.
Cool. Yeah, thanks a lot. Yeah.
Thanks a lot. Thanks everyone for coming. I'm gonna stop streaming right now, and it's eventually time to conclude our session today. So let me just get for a second to stop it. And then thanks a lot for joining us. And I will just ask Nancy and Tatiana to stay with us a little bit longer. And for everyone, good luck with Hackathon. Good luck with the book raffle. And we are looking forward to see you to our next event. Probably the most important part, wait until we still leave. So there is some exciting stuff remains for the May. So in May, there will be, can I say for now, it's like probably be Bayesian machine learning. So we're going to see how it evolves. So that's for PyLadies, which is really interesting and nice to join. And there is also another event. So I run in another group, which literally about MLOps workshops. And on 10th of May, we run federated machine learning with Flower. And this will be more focusing on how to secure it, about reverse engineering of shared weights, and all about that. So if you're interested, you can sign up as well. So now I will stop streaming just a second. And then, so it's almost concluded our session. And okay.